Hey guys and ladies, thank you to join me for this speech. Now it's not working. I hate you. Okay. I will walk around because I am sorry for you. I hate that, but I know you hate that, but I'm used to work in the room. So. My name is Marco Tusa. I am currently the manager for the consulting department in Percona, and I have been I am consultant for a very long time. I have been in MySQL IB in the professional service, this one, original one. I love MySQL and have been working with data and Oracle database first, and before that, other format. I'm 54 years old, 55 years old. So I start with Fortran. That's all. We are talking about dinosaurs. But still, I love new things. And I'm very excited to whenever there is something new and whenever there is something that we can test and that can help us to do our job better. And this is why at a certain point I start to talk with Renee, that we know each other for a long time, but and say, hey, what is this ProxySQL? This happened 2 years ago. And I start to investigate with him and apply and use it and do test cases. And what I'm going to talk today is why, while doing, experiment and testing, why we should use ProxySQL with Aurora and or in AWS platform in general, and what and how that can be useful in making that more solid and helping us in doing, not in strict security, because security is, but make it the platform a little bit more safe and stable. So who knows ProxySQL? Who have been working with ProxySQL here? Nobody. Virgin ground. Fuck. Okay. Maybe this is okay. I need to spend some money, some time. What is ProxySQL? ProxySQL is a proxy, a reverse proxy, not forward proxy. So if you're used to HAProxy, that's not it. Is a 11.7 proxy, meaning is protocol aware. He knows what kind of SQL you are sending. It was designed from bottom up to have high level of concurrency and connection. When I'm talking about high level, I'm not talking about 10,000 or 20,000. I'm talking about hundreds thousand, 600,000, 900,000 connection per, not queries, connection, right? So we are talking about very, very, very high level, very, very high load. And the important thing is that proxy has different blocks that allow you to process the whatever is coming in, and then eventually modify and define what you need to do with the SQL and with the value in it. And it's using multicasting, so you have a way to, let's say, reuse the threads that are there sitting and not active. So you may have, I don't know, 200,000 connection from the front end, but those will be only, I don't know, 100 or 200 to the back end. This is very high level, okay? Then if you want, I can try to discuss with Santiago and include a proxy introduction speech on the fly. Today, tomorrow, I don't know if we can do that. Maybe that will be more descriptive of the product. Probably that would have been better. AWS and Aurora. Who have you been working with Aurora? Anybody of you? Okay. That's perfect, right? Because you need to trust me now. You have no choice. Whatever I say will be, will be that. No, that's okay. Aurora is more or less the same thing, but for database. meaning it was designed bottom up to scale on many queries per second, high availability, everything is parallelized and everything is distributed. So at the end of the day, it is the database answer to high traffic and high availability requests, okay? So they can match, right? And by the way, it scale up to 64 terabyte per database instance, have a lot of feature inside that allow you to do, multiple replicas across availability zones, so all this kind of feature. So the point here is that up to version 2 of ProxySQL, that you obviously don't know because I don't know version 1 as well, we were not able to use ProxySQL with AWS Aurora because there was a problem. As the question that was raised before by, what's your name? Daniel. Okay, by Daniel. He was asking, some information about how ProxySQL managed the read-only flag and how ProxySQL eventually shift from one server to another server when they needs to do the failover. Well, that actually happened. Let's see if it worked. It worked with the read-only. Read-only is a flag inside MySQL that say this server is read-only, okay? And when you remove it, you can also write. And ProxySQL was doing, what it does is read this flag and say, okay, this server is read-only, so it can only be, is a slave, cannot be used for writer, as a writer, and so on and so forth. But the problem with Aurora is that actually that parameter was not used. It's not used. They use InnoDB read-only. And, it could be very simple, but actually that was preventing the utilization of ProxySQL with Aurora. And now I'm going to do a joke, please. This guy is the ProxySQL author, is René Canal. I don't know, you don't know him, because you don't know ProxySQL. But this guy is the initial author of the software. He had done a lot of work. He's a fantastic guy at personal human level and professional. I'm a friend of him, and I am honored to be a friend of him. But okay, so the problem exists, and he actually did a very simple patch on the code. This patch is available in version 2, as I was saying. And now you can implement the InnoDB read-only together with additional information. So you have read-only, InnoDB read-only, super read-only, and other stuff. At the end, this is going to be a list. So whenever you have a value in this list, you can expand what it needs to be done, right? So the concept is we can use it with Aurora. Now, when you use Aurora, when you set up your instance, and you set up multiple instances actually with Aurora, you have the Aurora Connector. And what you do is to say to your applications, use this connector, you link to that, and that will manage failover and whatever other things is going to be needed by your application. At the same time, AWS provide you read-only endpoint. The read-only endpoint will actually point to the instances that are read-only. Okay. Now, to use it with ProxySQL, you have to do a different thing. You have to connect directly to the instance name. So what you have to do is with this nice command, AWS read describe instance, or using the web interface, get the endpoint for each specific instances. And as you can see, I choose, and then you insert in a table. It's just a simple SQL command. You insert in the table the instance, the host group, and the weight, yes, the weight, which is mainly an element of that define the relevance, right? The ranking, which one is the most, the server needs to be the most utilized or not. Now, given the fact you are new to ProxySQL, it is very important to consider this. This is the host group. I'm going to talk about host group several times. And if you notice, this server has host group 70 and has host group 71. And then the other are all in 71. Why? Because ProxySQL register the server, but then works by host group. So by aggregation of servers. So whenever you have, for instance, in 71, okay, that means that you have 3 servers that can serve reads, okay? Because I define 71 that will be the host group for reads. And in a case like Pixie, Galera, do you know Pixie, Galera cluster, and okay. In that case, you should not have multiple writer, but if you, by any chance, have multiple writer at the same time, then you can have multiple servers under the 70 group. That could be 70, could be 10, could be 11, could be whatever you define. It's not, the number is just a convention for you. The other thing that is very important here is if you check, this server is not exactly, let me see, no, this server is DB1, no, this one was not exactly, yeah, B1B, in the same availability zone, is in a different availability zone. And in fact, I define a different weight in proxy, which means, yeah, okay, I have this server, and you eventually can use it, but don't use it. Only if all the others crash, use it, okay? Otherwise, keep it there. Why? Because it's in a different availability zone, and we will see why that is relevant in short. Anyhow, you have defined your nice setup in ProxySQL, and then the point is why should put an additional layer on top of my installation? Well, good question. And those are the numbers. If you want to have fun, when the presentation will be available, you can go through each one of those and see mainly this. No, sorry, this. Okay? That is why. Because using ProxySQL, you can manage, on a simple task, you can manage more or less 700 queries per second more than what you can do with a native connector from AWS. So it works much more efficiently. Why? Here. This is the latency distribution. Okay? So if you see, this is for the native AWS connector, and this is for ProxySQL. As you can see here, we have a very soft hill trend. So the data is parsed across a quite wide range of latency value. While here we have more, not only less latency, but it's also grouped, right? So it's more predictable. You can actually see what that your connection coming in is taking less, and comparing to the AWS connector itself is also more constant in how it behaves. And this is standard and keeps going and rolling. That was for a test done with Sysbench. This is a test done with, I came also from development, and I know that a lot of people don't like it. I still like Java. I'm sorry, I have to apologize for that, but I still like Java. So I develop a lot of code in Java for myself. And this, for instance, is the kind of code that you have, the kind of answer that you have using a Java application with Hikari connection pool mechanism, which is quite efficient mechanism. Still, you have two different trends. The first one is when Hikari opened the first time the connection, and then when it requests the renewal of the connection, okay? And you can see that, again, using ProxySQL, it gives you better results all the time, also for writes, okay? But, so that is at the end, as the end, it become clear why. Because, look at this graph. The first column here, the first trend here, is the test done against the native connector, and green is one instance, yellow is another instance, and what is this? China, I don't know, is the third one, right? The yellow one is the one in a different availability zone, okay? So that one never happened, and is never used. Now, what happened is the first is native, the second one is using proxy, native, proxy, native, proxy, okay? The first set of tests, read-only, read-only, write-only, and this is read and write. On the back, same, but with the CPU. And if you notice, except for writes that obviously have to hit exactly the same server for both cases, when using proxy, you can actually optimize the connectivity. And you can split the load much more efficient, in a much more efficient way. And automatically, an instance that is almost saturated by your traffic become available again for new traffic because you split the write and read load across multiple servers, which doesn't happen as you expect with the native connector. Why? Because the native connector, as I said to you, has two ways. One is you connect to the cluster, and the cluster will point only to the writer. Or you connect to the, or you connect to the reader entry point, which will connect and which will balance across all the readers. That's the point. So if you have a server that is in a different availability zone, and that will, your request will one time will take 10 milliseconds, and another time can take 200 milliseconds because it doesn't know, it's not aware of what is going on. The AWS connector doesn't know and will not be able to correctly balance against the incoming request. I'm losing you, I know that. So. Anyhow, okay. So summarizing, why we should use ProxySQL on top of AWS, well, and Aurora. Well, summarizing, as I said, the AWS cluster endpoints and reader endpoints are very limited, and of what they offer, and they have no idea what they're talking about the SQL coming in. ProxySQL is allow you to do very granular setup and define exactly which server, which instance needs to work with what. And last but not least, ProxySQL will allow you to do query caching, query rewrite, and blocking query and firewalling. And this is what we are going to cover now. So maybe. Oh, come on. First you go ahead and then. Okay, so now what? You have your installation, and we now, you need to put it, to open it to other people, to the application, to other DBA and whatever. So you start to secure everything. You secure the account using IAS and roles. You secure the network, creating, all smooth network and firewalling from that part, and then You secure the MySQL side, giving to each application, a specific user. Do never use common user, bad practice. And then you also secure ProxySQL with different encryption and password encrypted and SSL. And then you say, okay, everything is done. I'm happy. I can relax. At this point, my environment is ready to go. And that's not. This is wrong. Actually, you still have to face your worst enemy, yourself, and your developers, and your application, because there is nothing that you have done that will prevent shit to happen. Right? You know, in many, many years that I have been working as consultant, guess what was the 80%, the reason for 80% of the issues? Yeah, developers, but yeah, I know. But really, there is a specific thing. Can you guess? Bad SQL. All the time. Oh, my application, my database is going bad. You go there and say, oh, okay, come on. This is a query like that. You are joining 8 tables and you don't have the index in the right table. Oh, shit, really? What? Why? What's that? Oh, that's the guy. He just pushed the new code and everything stopped. It's right? How many times you have heard that? Yeah. And, well, that's the point. And this is what we are trying to do. So what we are trying to do now is to trying to stop stupid things to happen, like query with no filtering. Where? Oh, come on, happen, right? Of course, happen. Overcomplicated query. Yeah, you can do very simple things, and the guy just do 3 times more complex. Not query without index. And then also another thing that is very interesting is when someone from administration comes to you that I don't know who gives him the access to your database in production, but he has it, right? And he say, oh, sorry for that. I was just trying to look, you know, all the data in the last 5 years about all our users and trying to group by and know how much the value was for that. And say, yeah, that corresponds more or less to 2 billion rows reading one query. It's true, right? So you don't want to have that as well. But we need to be careful in doing filtering. All that thing can be done in proxy, but also proxy requires some specific rule. And one of my colleagues, TB, I cannot say that last name, did a very nice blog showing how doing bad rules inside proxy create slow down a little bit sorry, English, not my first language. Slow down a little bit the response time. So what we will do, we will split the thing into main part. One is secure by limiting action that others can do on the database, and use ProxySQL as firewall. What ProxySQL can use to filter things? It can use username, schema name, the client address, meaning the IP. It can use the proxy address and the proxy port. Then you can use the query that you are sending. So you can filter for any of this and decide by any of this to do something. What means doing something? Meaning you can change where the request can go. So for instance, you can decide, no, you are not going to production. No. You are going to that server that is a replica, the asynchronous replica that is sitting there, and you can do whatever billion query you want to do without stopping and creating any issue to that poor guy that, that's me, that has, have to keep the production up and running, otherwise the head will roll. Or you can do another thing, which is change the query. Rewrite the query totally. You can say, no, I don't want this. I will change in something else. or you can totally stop the query with a firewall rule. Simple. How to change how to filter by IP, okay? So let's analyze this command together, 1 second. So again, keep in mind, in ProxySQL, you insert rules and you do commands by SQL command. It's something that we DBA loves because it's consistent, it's not JSON, it's not, it's SQL, okay? It's very simple to identify. Anyhow, in this case, what we are doing is limiting the action by user IP, and ports, right? Actually, in this case, we are doing for IP. So what I'm saying here is that whatever comes from application test that comes from this specific node needs to go to host group 101. So you see rule ID, client address, username, and destination host group. Here we go. So what I'm saying mainly is any select that come from these guys from this specific IP goes to this host group, which may be server 123, right? Then the other rule will say, okay, this other guy that came from 51 will go instead to host group 200 that may have different server. Why that? Because, for instance, I have a distributed system. I have something in London and something else in Dublin, Barcelona, Madrid, whatever as you like. And I have the application that is currently connecting. Shlomi, I have to start a little bit late because Fred, and I will be late as well. Sorry. It's Fred's fault, not mine. Blame Fred. Yeah, blame Fred. Okay, thank you. So what happened is that maybe this application is in Barcelona. You want to send the request to the same data center, right? You don't want to. And same thing for the other application that is Madrid. And you have the data center in Madrid. And then you have replica between the two different data centers. And we are talking about selects in one case, and instead the other one is whatever here, you know? This is whatever, those are select. So maybe between the two data centers, only one is writing and replicating the data over to the other, and you just want to have the reads happening in the same location, just to give you an idea, right? That could be an optimization for performance. Or, yeah, I don't know if you remember, there was an option in MySQL, I am a dummy. Do you remember that? Yeah, there was a I'm a dummy option that allow you to say that MySQL was not going to process query without a where. Okay, now we can do the same thing with proxy. What will happen is that what I will do, I will create a rule that say whatever select is coming in, I can say select, insert, update, whatever you want. But in here I choose select. Whatever select is coming in and doesn't have where, guess what? Stop it. Of course, if the guy wants to trick you with this kind of syntax, he can put where 1 equal 1 and go ahead. But wait, this is a regular expression. We can catch everything, okay? We can do that. I just put this simple example because it is easy to read, but you can really put whatever regular expression to catch that. And that will actually stop whatever kind of stupid query coming from someone with that. I think I need to accelerate a little bit. No, yeah. Okay, this is another example. In this case, there is a subquery that don't have a where condition, and he's hitting the database with a full table scan, right? Again, you can have, with match pattern, you can, and regular expression, you can catch it and say, you know what? You can rewrite the query sorry, I think I did a mistake here. Yeah, I put I put the wrong thing. Okay. By the way, there is I will fix it when I will distribute the slide. What you can do is to say, okay, against this query, just take the value coming from the meal ID and then use it. This one should be this one should be /1 and /1 because is a parameter group, right? With a regular expression, you catch the parameter group and then you reuse the parameter group, and then mainly you can rewrite on the fly the query. And this is very simple. That will be cases of how you can stop query, rewrite queries, or redirect on the base of a specific filter that you have defined. Now, how it works with as firewall. This is IP tables. You are familiar with IP tables, right? Come on. Yes. Who is familiar? Everybody. Yeah. Okay. So, you know, a lot of rules, accept, send out, or forward, create chain, subchain. You can do all this with IP tables. How firewalling can work with proxy? More or less in the same way. The concept is important. The fact that you need to have a concept. You need to have the design in mind first, right? So what you can do is to create, as you do for IP tables, create rules that either they can go out directly, so just go directly and answer, or you can have rules that say, well, okay, go to a subchain and then process the whatever is inside the subchain, or if it doesn't match anything of those, you need to you can answer back. And here I want to show you this. A colleague of mine went to a customer, and the customer was having a lot of problem, saying, I have a lot of queries per second, and normally 5,000 queries per second, from 5,000 queries per second to 50,000 queries per second, actually. And they were really in trouble because they were saturating, you know, the connections that they were having. Then he started to investigate, and he saw that 90%, 99% of those were select one. Guess what? Ideas where they come from? No. Well, monitoring, yes and no, because it was connection pools. And, you know, again, developers. So connection pools use select one to keep the connectivity, right? To analyze the connection status. And guess what happens if you have a database that's serving 100 servers, application servers, 200 application servers. You have billions of select one. And when you use proxy, you don't need those because proxy is checking, he's checking the status of the server. You don't need them. So what he did, he put the proxy in the middle. You put a simple rules that say, whenever you get this, just send an OK message, not error message as before, an OK message saying, OK, everything is cool, go. Here we go. The traffic went down, and the customer was able to survive next season. Anyhow, so how does it that works doing a firewalling? In a very simple way, what you do is you can have a query, as I was saying before, a connection that comes in, does a query, and goes straight to the final destination. What time is it? Sorry. Just do you have just? Yeah, I'm out, but I still have 10 minutes. So, so what happened is that this query, for instance, can go straight to the final server, right? Why? Because in the rules that I'm defining a few things, which is the host group again. I'm saying whatever match you know, the specific value of PXE test, which is the user, that is for this specific schema, will be redirect to this host group, and will be the rule is active. Retry 3 times to be sure, and here we go. Apply, meaning this can be the last one, so the final destination, and no flag out, so no null. I have a null as a flag out, no jump. So, because in proxy, as when you have an IP tables that you define where you can jump to the next rule, same thing. You have flag in and flag out. If flag out is null, and you have apply, the rules will just finish there, and if there is a destination, like in this case, ProxySQL will redirect to that. This instead is apply later, so do a jump, okay? Same thing, but again, we have apply and flag out, and if you see, same user, different host group, no, same host group actually, but different apply, which is 0, and has a flag out. So in this case, I just want to go back here, you know, in this case, we have this, okay? I'm here, I have a flag out, I go to another rule, okay? Here we go. And the other rule will actually have the flag out as flag in to create the chain, as flag in, and then the apply equal 1, which means after you have done whatever you have done, just go ahead and pass it to the server. In this case, what I'm mainly doing is just filtering you know, that specific select, and say, well, you know what? That specific select, which is on host group 50, is select max ID, then can bypass the firewall, so can go to the second chain, but the second chain say, hey, guy, this is a select. Just let's change the host group. And I will send that to a host group that manage only readers, okay? But this is a cost. Nothing comes for free, okay? Just think about it. This is very powerful. I don't know if you realize how powerful it is, because you can really redirect and change the traffic of the SQL, things that was not possible before, okay? You had no way before to do this kind of thing, to stop crazy things like that, or to say, okay, I will get this query and I will put this specific query to those servers there for reporting. Oh, no way to do it. But that has a cost. And what I did is testing. And what I did is testing the cost without any rules. So this is the query process inside ProxySQL. There is a block that's called query processor, which processes the query and has a time that you can calculate. That you can eventually trace. And in this case, I was doing a baseline. Okay, so no cost, no query running, and the cost was 10 microsecond in general per query. Applying the rules as they are, so with the match, actually the cost jumps to, well, 32 to max and 30 to 30 microsecond, okay? So is 3 times more, well, 2 times more, which if you calculate against multiple thousand and thousand of query can affect a little bit, but not too much. But still, it costs, right? So do we have a way to do it better? Of course we do. In proxy, you have a very interesting information. In the table that is called Stat MySQL Query Digest, you have the information that say, for this query, I have this digest, and this digest will represent the query without parameters, obviously, and you can use it to transform the previous rule into this. So you see, there is not the select any longer, there is the digest. And same thing for the other, the apply later thing. You will have, again, you can use it. So why? Because that will become this. The cost will drop to 4 microseconds per query. And you see? This line that was following the trend of the queries just stayed down. And that is very important, because at the end of the day, what we will have is, with no query but no digest, we will have 10 microseconds. Using match digest, 30 microseconds. Using digest, 4 microseconds, because the query processor will actually he already knows what to do with that query, so it doesn't need to reprocess, and it's even more efficient. So summarizing, because otherwise people will start to sleep. ProxySQL is a very powerful tool. The version 2 can be attached to AWS and Aurora. It's very useful, very flexible. I invite you to test and to do some research around it. If you need help, you can contact me anytime, and I will be more than happy to support you. Keep in mind that your security level around SQL sucks. Period. There is no other thing to say. Why? Because up to now, you had no way to filter it, unless you do a very interesting thing, which was something that we have seen many times as well, that is using stored procedure. And inside the stored procedure, you insert the logic to filter things. But that is very bad for MySQL, because MySQL doesn't manage stored procedure very well. And it has a cost, but it can be managed as well. And you can have, you can calculate, it is deterministic. You can calculate the cost, and you have a way with, for instance, with Percona Monitor, you can identify what is the difference in the cost for query, for total cost for the queries. At the moment, there is no solution that implement an automatic way to take the digest from the stat table and populate dynamically the query rules. Is a manual work, but you guys are smart, and I'm sure that most of you will be eager to help and write some code and share with the community and help us to automate that part. That actually is what is missing. Thank you. Sorry if I have been a little bit longer, but we start later, a little bit later because the lunch. And if you have any question, I will be out. Otherwise, I will be around. Otherwise, you can contact me by email or by LinkedIn, Twitter, whatever. Thank you.